In this lesson, we're going to look at some of the more advanced techniques for taking derivatives for things that are somewhat more complicated than just basic polynomials. So our first rule we're going to look at is called the product rule. The product rule works when you have the product of two different functions. We've got function 1, function 2. And to take our derivative, what we're going to do is take the derivative of the first function times the entire second function. And then we're going to do the derivative of the second function times the entire first function. And often when we do the second piece, you might see in a different order, derivative first, and then the function, that's okay. So to look at this one, first one here, call this f, we'll call this g. You got two separate functions right beside each other. I want to take the derivative of this. So, take our derivative, we're going to take derivative of the first piece, so the derivative of f would be 4x times the entire second piece, x squared minus 2x. So this is f prime, this is g. Plus, now we're going to take the derivative of g. So inside the bracket, our derivative is 2x minus 2. And we're going to multiply that by the entire f. F was 2x squared. Just going to put b away for a second. And now we simplify these things. So we expand our brackets. So we're going to multiply. So we got 4x cubed. Multiply that one minus 8x squared. Do the next one. We got to multiply sort of backwards here, if you will. Plus 4x cubed minus 4x squared. And you can collect your like terms. So you end up with 8x to the 3 minus 12x squared. Okay, so that's a product. When you're made up of two different parts and pieces, take your derivative of each piece and multiply by the original. So we'll try the next one. Give it a try yourself. See if you can figure it out. And if not, check back in. Okay, so f prime of x. Okay, we'll call this f. We'll call this g. So derivative of f would be 4x plus 4. That's f prime times g. So keep it exactly the same. Plus derivative of g times f. Now f is that entire first bracket. So I'll write it all out. And there's your two parts. Okay, we got to expand, which means in the first part we got to do FOIL, right? So 12x squared plus 8x plus 12x plus 8. And then the second piece we got to multiply everything by the 3. So 6x squared, 12x, and minus 15. So we're just doing our distributive property, okay? Collect it all up, and you should end up with 18x squared, 32x, and 8 minus 15 is minus 7. Okay, try our next one. Okay, this one's got 3 parts. Okay, the same ideas we use in a 2-part series, we can use in a 3-part series. We're just going to have extra pieces. So we'll call this f, g, and h. So our derivative will be the derivative of f, which is 2x, times g and h. Okay, so we have f prime, g, h. Okay, plus, now we're going to do the derivative of g, so g prime, that's 2x, times f, which is x squared plus 1, and h, x squared plus 3. So this is f, this is h, plus, our third part, we got to take h prime now. So h prime is 2x, and f is x squared plus 1, and g is x squared plus 2. Now we get the fun job of expanding all these. So I'm going to leave the 2x out front. I'm going to do FOIL inside. I'll get x4 plus 3x squared plus 2x squared plus 6. I'll do the same thing for the next one. So we'll get x4 plus 3x squared plus x squared plus 3. We're just doing FOIL with each pair of brackets, right? And the last one, x4, 2x squared, x squared, and 2. I can multiply everything through by the 2x's for each set of brackets just to get rid of that piece. So 2x5 plus 6x3 plus 4x3 plus 12x. So we just distributed each one, all 4 of them. Same thing for the next one. So 2x5 plus 6x3 plus 2x3 plus 6x. And same thing for the last one. 2x5, 4x3, 2x3, and 4x. Now we've got a whole bunch of like terms we can collect. We have 6 x5s. We've got a bunch of x3s. I think we have 24 of them if we do it all, right? And then the x's at the end, we have 22 of those. Okay. So when you're dealing with the product rule, just remember, I got to take the derivative of the first part times the rest of it. Derivative of the second part times the rest of it. It doesn't matter if we keep adding more brackets, it just means more parts and pieces, more plus signs between sections. Okay, so that's rule number 1. Rule number 2 today, we're going to talk about the chain rule, or the power rule, which is sort of something we already talked about. We talked about when we have a function, or we have x to the n, we'd bring the n down in front and do n minus 1. Well, the same thing is true, except for instead of having just the letter x now, we're going to have this piece being a function itself. So when I take my derivative, my exponent still comes down in front. I still subtract 1 from the exponent, but because the inside piece of the function, I have to take its derivative also. Okay, so just to show you, here's our first example here. We'll give it a try. So my derivative is, my 5 is going to come down in front. Okay, my base is going to stay exactly the same. I'm going to subtract 1 from the exponent. And then I'm going to take the derivative of the inside piece. So if this is g, and this piece in here is going to be my g prime, which will be 6x. Okay. We simplify it by multiplying these two things together. If I multiply those together, I get 30x out front and 3x squared minus 5 to the 4 inside. That's as far as you go. There's no point expanding the 4 brackets are all the same. It's kind of more simple the way it is. Okay, we'll try the second one. So y prime, I multiply, just like we did before, it's a constant. 2 times 3 makes 6. X squared, x squared minus 6 to the 2. And the derivative of the inside piece is just 2x. And multiply the first and last things together, we'll get 12x. And x squared minus 6, all squared. Okay. Try a slightly more complicated one again. Here we got this fraction idea. We know when we're taking derivatives, we don't like to have letters on the bottom, so let's fix that. Before we take our derivative, let's bring the entire bottom up to the top. So the whole expression on the bottom, which is all of this, is to the power negative 1. Okay, the one out front is the one that was up here. Right? That hasn't changed. It's just we've turned it into multiplying instead of dividing now. So if I want to take my derivative, I got to do the multiplying times the constant. And keep the whole base the same. Subtract 1 from my exponent times the inside derivative. Which if we rewrite it and do our multiplying idea, these two together, we'll get negative 2x. And I bring my exponent back to the bottom, I'll get x squared minus 3 all squared. Okay. So the things that we can do with polynomials, we can also do with rational expressions, ones that are fractions. Okay, I got 3 more to try we're going to go with. And these ones I want you to differentiate, take my derivative, but don't simplify them. Okay, we'll worry about simplifying another day when we get to some techniques with that. So a mixture of things here. So let's take our derivative. This looks like the power law and kind of the product law all at the same time. So derivative of the first piece, call this f, call this g, would be 2 times the second piece. Right? This is f prime times g plus derivative of the second piece would be 3 times x plus 3, subtract 1, we're using that power law, or the chain rule, that's g prime, times the derivative of the inside, which is just 1, which is kind of nice, times the whole first piece. Okay, so all of this was your derivative for g. And don't forget to multiply by the f part afterwards. Let's try the second one. And the 4 is going to come down in front, times 2x cubed plus 1 to the 3. times the derivative of the inside piece, okay, times the derivative of the whole second piece. So lots of parts and pieces to keep track of. Think of all this as being your f prime, or this is f, times g. This is g, plus. Now you go to the g prime now. So 2 times 4x squared plus 7 to the 1 times the derivative of the inside piece times the entire first piece. 2x cubed plus 1 to the 4. So all of this is g prime, and there's your f. Okay, and the last one, we've got 3 parts and pieces again. We've done one of these before. Let's give it a try here. So y prime, derivative of the first piece times everything else. Right, plus derivative of the second piece, which is just 2, times everything else. Plus derivative of the third piece, which is 2, times 3x squared minus 5 to the 1, times 6x, that's the derivative of just that part, times everything else. So we have an x squared and a 2x plus 1. I said we didn't want to simplify these ones. We're going to leave them just the way they are. We'll learn how to simplify them a little bit more 2 lessons from now. Okay, so that's introductory to the sort of more complicated versions. You kind of need to practice these ones because they can get really complicated really fast, and it's easy to lose track of pieces if you're not really careful. So there's the homework. Give it a try, and we'll chat tomorrow if you have trouble with stuff.